far. But for now, actually, we still have one last topic on the agenda, which is actually from our POLYBIOSKIN partner, IMT-Mines Alès, showing us a bit more about the LCA methodology and how POLYBIOSKIN can fit in here. So I would just quickly hand over to Rosemarie to give us the presentation. So the floor is yours.
Okay. It's okay?
Yes, we can see it. It's perfect.
Okay.
Thanks.
Okay. I talk concern cycle assessment and life cycle cost assessment methodologies. So the outline of my talk will be the following. I will begin to present a life cycle assessment methodology and then life cycle cost assessment. And then I will present the applications for the POLYBIOSKIN project with an example, which will be a top sheet for the composition which was developed in the project, and with a comparison with a commercial top sheet from a given company using polypropylene. And I will conclude with some data. What is LCA? It's a standardized tool to evaluate the environmental impacts for a product or a process. So it's a global method, and all the life cycle is studied from extraction of raw materials to end-of-life products, and different kind of scenarios of end-of-life can be considered. It is a multi-criteria method, so several environmental impact can be viewed, studied with the same tool. So it's possible to envisage different kind of parameters and to determine the variations of the impact. The objectives of the LCA are to validate an ecological product or a process, in comparison or not to a reference one, to determine hotspots. The hotspots are the most impacting steps or processes in the life cycle. For example, transportation or the stage of the product. Also to identify transfers of environmental impacts. So transfers between life cycle steps, but also from one impact to another impact in the same life cycle step. For example, some processes can reduce the climate change impact, but increase, for example, human toxicity impacts or other kind of impacts. This method is defined from an ISO standard, and there are lots of additional standards which define the specific use of the method. This method is distributed in 4 steps. The first one is to define the goal and scope, which product, process, which public, what are the boundaries of the system. An example of boundary is cradle to grave, but it's possible to restrict the boundary. Which impact calculations method, which impacts. So there are different kind of calculation method according to the kind of software used, but they have all to respect the ISO standard. So the first stage is the life cycle inventory, the quantification of all the inputs, energy, water, use of land, raw materials, all the emission in the air. So it will be obtained with measurement. For example, when you have an extrusion machine, you can make some calculations of energy consumption, also databases, scientific literature, and also patents. Then the life cycle impact assessment is made with LCA softwares. It uses scientific models to aggregate data from the inventory, and so it's possible to get a final environmental impact. Each category of impact can be calculated. So the main software used for the main people using these tools are CIMAPRO, Gabi 8, we use it in this project. There is also Open LCA, but the problem for some softwares is the availability of the databases. You have also to pay databases, and when you want to update the databases, you have to pay a lot. So I continue. The interpretation is the last stage. Analysis of the results, so identification of the hotspots, the transfer of pollution, and at the end there is a critical review of the study, and it entails priority actions and recommendations. Now I will move to LCC methodology. LCC is life cycle costing. It will cover the cost of project, processes, and systems across life cycle stages. But there is some main differences between LCC and LCA. LCC at the beginning was defined from the point of view of the investor. So you can read the purpose, the scope, the flow, the aggregations, the locations, all is based on monetary flows, the cost and benefits. It's completely different from the LCA, in which the flows are about materials, energy, and another point is the discount rate. Discount rate corresponds to what happens in the future, the gains and the losses. So there is a discount rate in LCC, but not in LCA. So here you have two different kind of approaches. So the challenge is now how to combine environmental analysis through LCC and LCA. And various methods have been developed and published, but the most relevant method or methods, because there are different variants, it allows costing analysis on the same boundaries. So the LCA will use the same functional unit as LCA. And there was a method developed by the CETAC 20 years ago around is environmental life cycle costing. All costs will be associated in the life cycle. These costs are costs covered by one or more actors in the life cycle, including consumers and citizens. And all these costs will be converted in real money flows. There is no international standard method, but there is a code of practice. I mentioned a reference. And later, another method was developed, the social life cycle assessment, in which the social impact, the social involvements are detailed in the method. So some benefits can be obtained with social life cycle assessment, and conversely to money calculations in ELCC in some cases. But in the POLYBIOSKIN project, we stopped at the level of the ELCC. So the interest of ELCC is that it takes into account externalities. I give a definition of externalities. It's a value change which is not included in the price. It can correspond to side effect of economic activity. So in some cases, it can be beneficial, but we have to take into account the environmental damage in this case, so some pollutions which can be caused by the production of a good. The externalities in LCC are only considered as risk or cost, but in ELCC, they will be monetized. So it means that they will be calculated and added to the cost, the basic cost of the products. And there are different kind of principle of monetization. So WYTP, WYTA, it corresponds to what someone accepts for a change, a positive or negative change of his environment. But also there are other methods, but based on damage cost, prevention cost. I will give some example. The cost rate of CO2 is close to 200 euros per ton now. And there is a kind of convergence of different approaches. So in Gabi 8, the UBA method is used. So the ton of CO2 costs around 200 euros. But in the method, the other impact can be monetized. For example, sulfur dioxide, nitrogen oxides, the fine particles, and also the volatile organic compounds. So in the POLYBIOSKIN project, we use three products. And for each product, an inventory was made. It is a current work now because we have to finish. We use the Gabi software with a recycle method, which is well relevant to Europe. And LCC was based also on Gabi, but also on Cambridge Engineering Selector, which use EcoInvent database and economic data of materials and additive suppliers. We compared with an oil-based equivalent. So it was focused on the top sheet. The top sheet is a polypropylene non-woven film in standard diapers, but in POLYBIOSKIN studied the top sheet was made using a mix of bio-based polymers and also additives and specific fillers. So this formulation is more complex than the commercial reference one. We compared two weights are a little bit different, but it corresponds to a reality. Around 2 grams PP non-woven produced in China, and the 2 grams of the POLYBIOSKIN formulation. The boundaries correspond to the extraction of raw materials up to the end of life with different scenarios. The end of life scenarios correspond to a production in Europe, a certain distance of transport for the top sheet waste, industrial composting for the POLYBIOSKIN top sheet, but for the standard top sheet, a mix of landfill and incineration with energy recovery. It corresponds to a median possibility in Europe. The inventory using EcoInvent and Gabi, impact assessment also. Some results for the global process. You can notice that for the climate change, the POLYBIOSKIN top sheet is less interesting than the standard top sheet. It is the same for human toxicity. Concerning terrestrial acidification, also the POLYBIOSKIN top sheet is less interesting. So what you have in percentage are the impacts. Conversely, for freshwater ecotoxicity, the standard top sheet is less interesting. But if we focus on only the end of life, for the end of life due to the composting, for the climate change, for the stratospheric ozone depletion, the freshwater ecotoxicity, and the human toxicity, clearly the POLYBIOSKIN top sheet is more interesting. But now let's move to the economic approach with ELCC. In the two tables, you have the 4 stages: materials production, processing, transportation, end of life. For the basic cost, the cost of externalities, the sum, each for the top sheet of POLYBIOSKIN and the reference top sheet. What you can observe is that the more impacting stage is the material production. we can notice that on the whole, the cost of the polybioskin top sheet is twice in comparison to the reference top sheet. And the externalities are significant, around 20–25%. If we look at the material processing, it is proportional, in fact, because it is extrusion. Concerning transportation and end of life, the costs are minor, but at the same level. Concerning transportation, more products in the composition of the polybioskin top sheet, so it leads to more cost. And concerning the end of life, it is the reverse. It is less expensive due to the possibility also to send the compost. It's a kind of hypothesis. And at the final, we can stress on the main cost, which is materials production. So it will certainly lead to similar result with other components of the diaper. The conclusions, we have for the moment studied 19 impacts for the top sheet. 12 are higher for the polybioskin top sheet. 5 are similar. 2 are lower for the polybioskin top sheet. The main impact come from the production of the top sheet, production of raw materials. The reference top sheet corresponds to a less complex processing, so it explains this effect. More costs, more externalities for the polybioskin top sheet, despite a more interesting end of life. The cost of externalities are significant, so it justifies the use of ELCC instead of a basic LCC. Finally, the main interest of polybioskin top sheet is the end of life. Thank you for your attention.
Thank you.